Welcome to The Explainer. Today, we're going to unpack something truly fascinating and honestly, a lot of fun. We're taking the highly technical, globally renowned principles of lean manufacturing and the Toyota production system, and we're going to learn them through, well, a paper airplane game. I know, it sounds a little simple, but as you'll see, the insights we pull from this are incredibly profound. I mean, reaching astronomical efficiency with a paper plane, it's a great concept. But what's really cool here is that this represents a real hands-on simulation. This isn't just some childish toy, it's actually a meticulously designed experiential game put together by the Lean Land Laboratory. It literally takes a comprehensive 4-hour workshop on the Toyota production system, or TPS as we'll call it, and condenses it into this dynamic, simulated factory floor. By building paper airplanes, you actually feel the pain points of traditional manufacturing and you experience the breakthrough solutions of lean firsthand. So here's our flight path for today's simulation. We'll kick things off with an introduction to TPS, then we'll jump into the airplane game setup. After that, we're going to run our factory through a traditional push system, completely revolutionize it with a pull system, refine the whole operation through Kaizen, and finally look at the ultimate goal. Let's get right into it. Starting with Section 1. Introduction to TPS, the two pillars. Because before we fold a single piece of paper, we've got to understand our architectural foundation. And this architecture is brilliantly illustrated by what's known as the TPS house. If you look at the roof, that's the overarching goal of this entire system, right? Achieving the highest quality at the lowest cost with the shortest lead time. But a roof needs support or the whole thing comes crashing down. So the absolute crucial point here is that this goal rests entirely on two massive pillars. Over on the left, you've got just-in-time, which is all about continuous flow and a pull system, basically making only exactly what is needed. Then on the right, you have Jidoka, which translates to automation with a human touch. That means we have the ability to immediately stop and notify someone if there are any abnormalities, ensuring zero defective products move forward. Everything we do in our game today is designed to build up these two pillars. Moving to Section 2, the airplane game setup, building the factory. So I want you to imagine stepping onto your brand new manufacturing floor. Here is our lean factory game kit. To run the simulation, we're going to organize a team of 8 workers, plus a plant manager and a timekeeper to track all our metrics. And look, we don't need heavy machinery for this. Our raw materials are literally just 500 sheets of A4 paper. Our tools? Super simple. Scissors, a glue stick, a ruler, some markers, a quality gauge, and these very specific cards called Kanban squares. So here's how our assembly line actually works. Every single paper airplane has to pass through these 7 strict sequential steps. Process 1, drawing specific lines to divide the paper into 4 quarters. Process 2, cutting those quarters out. Processes 3 and 4 are when we make specific, standardized folds for the wings and body. Processes 5 and 6 are combined, that's checking the plane against our quality gauge and pasting on 2 logos. And finally, Process 7. This is the ultimate customer validation, a 3-meter test flight. If that plane doesn't fly 3 meters, it's a defect. We take our paper aviation very seriously around here. But we're running a factory, so how do we know if we're actually doing a good job? Well, we track these critical KPIs, or key performance indicators, during every 15-minute game round. We track our total production, the number of certified airplanes that pass that final flight test, and of course, the defective ones. We're also keeping an eye on lead time, which is how long one single plane takes from start to finish, and individual productivity. But I'll tell you right now, the single most revealing metric we track is WIP. Let's define that clearly because it is absolutely crucial. WIP stands for work in process. We are talking about all the materials sitting in the work areas or piled up between the work areas, all the way from process 1 up through process 6. It even includes airplanes that haven't been tested yet. Why does this matter so much? Because in the real world, WIP represents tied-up cash, hidden defects, and massive clutter on your factory floor. It's essentially unfinished inventory just sitting there, waiting around, doing nothing for you. Which brings us to Section 3, the push system, making lots. This is going to be our baseline factory run. So in Game 1, we operate using traditional manufacturing, the push system. You might know this as make-to-stock. It perfectly mirrors the old Ford and General Motors styles of production. The rule for this first 15-minute round is pretty straightforward. Workers produce in large lots of 4. As soon as you finish your 4 items, you aggressively push them downstream right onto the next station's desk, and you do not care whether they are ready for them or not. Your one and only job is to build your specific part as fast as humanly possible. So let me ask you, What do you think happens to the factory floor when every single worker just builds as fast as possible? When they completely ignore the capacity of the person sitting next to them? Well, you can probably guess. Some steps, like cutting paper, are naturally way faster than intricate folding. So within minutes, massive piles of half-finished paper airplanes, huge amounts of WIP, start piling up on the desks of the slower stations. It is quite literally a paper avalanche. Workers get incredibly stressed out, defects get buried deep in those piles, and the lead time completely skyrockets because a single plane gets stuck at the bottom of a stack of 20 others. It is absolute, utter chaos. Okay, now for the fix. Section 4, the pull system, or just-in-time. This is where we implement the revolutionary Toyota solution. To fix all those bottlenecks we just created, we introduce a new tool in Game 3, the Kanban. A Kanban is simply a visual signal card used to pull production and prevent overproduction. We take these Kanban squares and we place them between every single workstation. Now, what's really fascinating about this simple visual signal is how it completely flips the psychology of the worker. The new rule is this: you can only build a plane when your Kanban square is empty. If there's a plane sitting on your square, you stop working. Literally, you just wait. The demand is actually triggered from the very end of the line, the test flight. Think about it. When a finished plane is taken away for a test flight, it leaves behind an empty square. That empty square signals the previous worker to make one to replace it, which then leaves their square empty, signaling the worker before them, and so on. Production isn't being pushed, it's being pulled backward, piece by piece. Let's put these two mentalities head to head. The Game 1 push system relies on lots of for, a make-to-stock mentality, and completely ignores downstream capacity. The vibe is just make as much as you can. On the flip side, the Game 3 pull system uses a lot size of exactly one, a make-to-order mentality, and patiently waits for a Kanban signal. The vibe there is make only what is requested. And if you want proof, just look at the hard data from the actual game evaluation boards. The black line is our work in process, and the orange line is our lead time. Over on the left, that's the push system. WIP is just through the roof, hovering around 40 to 80 units of unfinished paper just cluttering up the desks, and lead times are correspondingly massive. But look what happens when we switch to the pull system on the right. It's a game changer. WIP dramatically plummets to single digits. Lead times crash down from hundreds of seconds to just a fraction of that. Almost instantly, the factory floor becomes calmer, cleaner, and vastly more responsive to actual demand. Which leads us to Section 5, Kaizen, continuous improvement. Because in Lean, you're never truly finished improving. Kaizen translates directly to continuous improvement aimed at the thorough elimination of muda, which is the Japanese word for waste. Now, the absolutely crucial point here is that Kaizen does not mean walking out to the floor and telling the workers to just fold paper faster or sweat more. Working harder without fixing a broken system just creates more fatigue and more defects. Instead, we want to optimize the actual flow by removing wasted movement, double handling, and unnecessary waiting time. So in Game 4, the team actually stops producing entirely. They spend 30 minutes brainstorming using analytical tools like this standardized work combination table. They get really granular, meticulously measuring the exact manual time it takes to do every single microstep: drawing, cutting, folding. They also calculate the takt time, which is basically the rhythmic heartbeat of customer demand. Then, empowered by all this data, the workers reorganize the factory layout themselves. They might combine steps, they might move desks closer together to reduce the waste of walking, or they reassign tasks to perfectly balance the workload across the whole team. They literally engineer the waste right out of the system. Finally, Section 6, the ultimate goal. We've built the factory, we've felt the pain of the push, seen the undeniable logic of the pull, and optimized everything through Kaizen. And it all culminates right here. A perfectly folded airplane sitting squarely in our quality gauge. This single image perfectly encapsulates our two foundation pillars from the very beginning. The quality gauge itself represents Jidoka. We have a foolproof system that immediately stops and highlights an abnormality if a plane is folded the wrong size. And the Kanban square it's resting in, that represents just in time. We are only producing this highly checked quality product exactly when the next station needs it, ensuring a continuous, smooth flow without huge piles of wasted paper. Taiichi Ono, the visionary creator behind the Toyota production system, hit the nail on the head when he said, "The most basic way of thinking in the Toyota production system is to develop a method to make what sells as much as it sells when it sells as cheaply as possible." That right there is the ultimate victory condition of our paper airplane game. And honestly, it's the holy grail of modern manufacturing. We've seen how just a few simple rules can completely transform a chaotic paper folding exercise into a world-class manufacturing simulation. But the lessons of push versus pull, the hidden dangers of whip, and the empowering nature of Kaizen, they apply way beyond the factory floor. So I want to leave you with a challenge. Take a look around your own desk today. Look at your own email inbox. Look at your team's daily processes. Where are your bottlenecks? Where is your paper avalanche? And how will you identify and eliminate the hidden waste in your own workflow today? Thanks so much for exploring this with me, and I'll catch you on the next explainer.